We code all the time in C++ using mathematical expressions. And while you may have seen memes on the internet that have simple mathematical expressions like this, as a matter of fact, I've lifted this directly from a meme from the internet. And it's such a simple mathematical expression that you may be surprised to see in the comments section that half the room thinks the answer to this expression is one thing and half the room thinks it's the other. And there's no general consensus, and people are name calling and using sarcasm and throwing around credentials and even justifying on both sides pretty logically how they got their answer and why they are correct. And while this particular expression exploits the order of operations and a subtle misunderstanding that people can have of the order of operations. And you could think that you even follow the order of operations correctly to solve this and still get it wrong pretty easily. So let's illustrate how we can get it wrong even though we think that we are getting it correctly. And so I learned my order of operations in school like this: PEMDAS, right? You may have learned something similar. I even learned a cute little sentence to go along with it. Please excuse my dear Aunt Sally. And each of these letters stands for a particular sequence of operations that you perform on any expression. And if you perform those operations in this order, then you should get the correct answer. And the first letter, P, stands for parentheses. You evaluate anything in parentheses first. And then you evaluate any exponents, anything that's being squared or cubed, or anything that's having the root taken of it. And then multiplication, division, addition, and subtraction. So let's follow this order of operations and see how easy it is to get the incorrect answer, as a matter of fact. So first we do our parentheses. And so we got some stuff in parentheses here. We have this 1 plus 2 bit. And so not to skip any steps, let's just simplify this. So this will be 6 divided by 2. And now we do the stuff in parentheses. Well, 1 plus 2 is 3 here. Next, we do any exponents. Well, we don't have any exponents in this, so we can safely skip that step. Then we do our multiplication. Well, we have some stuff multiplied. This is 2 times 3 here, so this would be 6 divided by, well, 2 times 3 is 6, and we can move on to the next step now. Then we do our division. Well, all we have left is a division problem. 6 divided by 6 here, so our answer must be 1. We don't have any addition and subtraction. We are done, right? And this is still incorrect. The correct answer is actually not 1. And, well, if that surprises you, then, well, pay attention to this. Now, the reason that this is incorrect is because, well, multiplication and division, as it turns out, are inverse processes. So what does that mean? Well, you can start off with something, for instance, say you start off with 10, and you can make that 10 3 times bigger by multiplying it by 3, and well, your result will be 30. And then you can take that result, and now instead of multiplying by 3, you can divide by 3, and you will make your result 3 times smaller. So you actually end up with the 10 that you started off with. One thing here undoes the other. If multiplication makes the thing 3 times as big, then division makes it 3 times as small. And so these are sort of equivalent processes. They just go in different directions, if you will. The same thing with addition and subtraction. So, for instance, if you had one thing in your hand, and then I gave you 4 more things to hold, well, now you got 5 things in your hand. Well, if I took away 4 things from your hand again, you're back to the one thing that you started off with. And so once again, addition and subtraction are inverse processes. They just do the same thing essentially, but they just move in different directions. One of them isn't more powerful than the other, and so one of these things shouldn't be prioritized over the other. As a matter of fact, in your order of operations, this could have been, for instance, PED or however you want to say it. We just put it this way, PEMDAS, because, well, it was easier to pronounce. This is just a list, but once again, multiplication doesn't necessarily come before division. Addition doesn't necessarily come before subtraction. And if you have a problem like this stage of the problem right here, where you have just both, then being that they're equal, You don't prioritize one process over the other. You just work this out from left to right at that point. So here is the step where we went wrong. We didn't work from left to right when we just had division and multiplication in there. We actually prioritized multiplication over division and started working from right, because we evaluated this multiplication part first, to left, and that's how we went wrong. Instead of that line, well, let's just start over real quick. We'll copy and paste the original problem down here just to make this clear. And well, the second line was good. We're actually correct in assessing that we should evaluate what was in parentheses first. And so we end up with 6 divided by 2 times 3, which was correct. So I'm just going to copy and paste that second line down there. But instead of doing multiplication first, like we did, working from right to left and then doing division next, because these two processes, multiplication and division, are equivalent, they're just inverses of each other, we should have just worked this out from left to right. And instead, we should have gotten, well, 6 divided by 2, the first part, the division part, well, that's 3. And then we have this times 3 business at the end. And then, well, now the final result is 9, and that is the correct answer. And so we're going over this because, once again, we code with mathematical expressions all the time. And if you don't know your order of operations and you don't set up your calculations correctly within your program, you may get some hard to find bugs. You may get some results that you didn't expect. But don't take my word for it. Let's just comment all of this stuff out here. And let's take the original expression. We'll copy and paste this down there, and we'll see what C++ thinks about it. So let's see out to the screen, and I'm just going to paste the original expression in there and then drop down a line, right? Now, I do have to change one thing about this. If you've seen the video on explicit multiplication, you'll know that this line will give an error if we will try to run it as is, because we have to explicitly multiply this 2 times this business in the parentheses there. And to do that, we just put our star operator in there to explicitly multiply those things. And now when we run this, well, we get the correct answer of 9. And so the order of operations was followed properly. Now, my advice, and this is how things are sort of generally done in a lot of code, is to overuse your parentheses, because it clears things up quite a bit. So for instance, there's no ambiguity here if we put a set of parentheses around these things up front. 6 divided by 2, well, that's 3. And then 1 plus 2, well, that's 3. And then 3 times 3, that's 9. And it doesn't change the answer at all. When we run this, we still get our 9 there. So to make things more clear, I would use redundant parentheses. It's quite a common practice. And as a matter of fact, if you wanted the 1 out of there, you can parenthetically do that. You can say put a set of parentheses around this bit of the equation. And now when you run this, or expression, excuse me, now when you run this, you do get your 1, because, well, when you have a couple of sets of parentheses, you work your inner parentheses first. And so 1 plus 2 is 3. 2 times 3 is 6, and 6 divided by 6 is 1. So either way, the order of operations is explicitly clear because you use your parentheses, even though you didn't have to, and it results in a clearer expression, easier to read, and it guarantees the result that you were going for. So I would use extra parentheses in your expressions, whether you need them or not. All right, see you in the next one.